For section 2.3, the two problems I'm going to do to help you out is going to be one problem where they ask you to use long division to divide two functions, and then the second one I'll take a look at is where we end up using synthetic division to divide, which of course we know is a shortcut for long division. Alright, so looking at the first one, use long division to divide. Alright, so remember when you do this, you want to look for any terms that are missing. So for example, I notice when I look at this function, I've got an x to the third, I've got an x squared, but I don't have an x. So I'm going to add plus 0x or minus 0x. I don't have to, but it's a good idea for spacing. Same thing here, I've got x squared, but I don't have an x term. It's just a good idea for spacing. Alright, so to divide by, let's go ahead and write this out. It's going to be 2x squared plus 0x, again doing this for spacing, plus 1. And then I'm going to write 6x to the third plus 10x squared plus 0x plus 8. And now I've got everything set up and I can go ahead and do my division. Alright, so now I start to do my division, and when I do this, kind of like long division with numbers if you remember when we did that in class, for this though, all you want to do is you want to kind of focus in on the front terms, and you're asking yourself, what should I multiply this term by in order to get that term? So look at the numbers first if that'll help you out. Well, I've got a 2 here, I need to get a 6, so I need to multiply by 3. Now look at the variables, I've got x squared, I would need one more x, so I need to multiply by x. So I'm going to multiply by 3x, and I'll go ahead and put that up here. And then like long division with numbers, you're going to take the 3x, or whatever term is up here, and distribute that to all three of these. So take 3x and multiply by 2x squared, that gives you 6x to the third. I'm going to put that under the x to the third term here. 3x times 0x is going to give me 0x squared. And 3x times 1 will give me 3x. And again, because I've put the 0x and the 0x here, notice how the squared terms line up and the x terms line up, which is good. Now when I go to subtract, it won't give me a problem. I won't end up subtracting from the wrong spot. Need to put parentheses around this whole thing because I am going to subtract this entire quantity. So be careful with the double negatives. It's 6x cubed minus 6x cubed. They cancel, the first terms are supposed to. It's 10x squared minus 0x squared, so that's of course going to give me 10x squared. And it's 0x minus 3x, so that'll give me negative 3x. And then however many terms you have over here that you haven't used, just go ahead and drop those down. So I just have the 8 that I'll drop down. And good news is if you can do that, then you can do long division. You basically just have to do that step over again. So again, look at just the first terms and ask yourself, I've got a 2 here, I need to have a 10, so I'm going to need to multiply by 5. I've got x squared, I've got x squared, I don't need to do anything. So all I need to do is multiply by a positive 5. And I'll go ahead and put that up here. Just like you did before, take that positive 5 now and redistribute to these three. So that would give me 10x squared. It will give me 0x, and it will give me a positive 5. Again, parentheses around the entire quantity. I'm subtracting. The first terms are supposed to cancel. Just double check to make sure they do. It's 10 minus 10. Sure enough, they do. It's negative 3 minus 0, so negative 3x. And then it's 8 minus 5. And so that'll give me a positive 3. And like I said, be careful. If this was a negative 5, you'd have a double negative, and then you'd have 13 here. It's an easy mistake to make. You just have to be careful when you're doing this. Alright, then how do you know when to stop doing this? Well, how you know is when you look at, say, the original term, or that term, or now this term. Notice the degree here was to the third, to the second, to the first. Look at the degree here. It's to the second. When the degree here is less than this one, then you can stop. So like this was x to the second, this was x to the second. I know I needed to make one more step. Now that the degree on this is 1 less than this, I can stop. And so my final answer is going to be, here's your kind of whole number part, if you will, 3x plus 5, and then this is your remainder. And so you can say it's plus a negative 3x plus 3 over the 2x squared plus 1, the thing that we were originally dividing by. And there's your long division problem. You may want to look in the back of the book to see what they do. They may actually factor a negative out of this, and so you might see this for an answer instead. You just have to recognize that it's the same thing. If I factor a negative out, they'll change this now to a negative. that would become a positive 3x and a minus 3 over 2x squared plus 1. So these two answers are actually the same thing. So if you saw that, but this is what you had written down, you're right, it's fine. I will give you full credit for it. You just have to be careful and understand that, yep, that's the same answer that the book has. All right, so that's doing long division. For the most part, once you kind of catch on to it, you'll be fine. It's just you have to kind of catch on to it a little bit. Next one would be doing a problem very similar. This time you're going to do what we call synthetic division. So it's a shortcut for long division. And the reason that I can do it on this one is I'm dividing by a linear term. If you look back here, I was dividing by a quadratic term, and that usually means that I can't do synthetic division, that I'm going to have to actually do long division. So if I have something where I'm dividing by a linear term, well, then I can actually use a shortcut and I can do synthetic division. And depending on the book that you use or the teacher that you look at, they may write this out a little bit differently. But you're going to do the same thing that you did for the last problem. I'm going to write down this function, and if I notice anything's missing, this time I actually have to account for it. I didn't have to in the long division, but I have to here. So I'm going to write down 3 for the x to the third term. I'm going to write down negative 16 for the x squared term. It doesn't matter if it's positive or negative 0 for the x term, and then 8. And then the way I like to do it is I like to put a little kind of a half rectangle around this, and underneath the last number, the 8, I put another half rectangle. That's eventually where my remainder will be. Another way that you can do this is if you have the 3, the negative 16, the 0, and the 8, you might see some teachers do this, and that's fine. Either way is fine. If you learned this last year and you're more comfortable doing it that way, that's absolutely fine. I don't tend to do it that way, but that, like I said, I'll be able to read it and follow it, and it's no big deal. Alright, so now how do I figure out what number to put here, or if you were using this, how do I figure out what number to put here? Take that linear term, set it equal to 0, and solve it. And of course, if I did that, I would get x equals 4. That 4 is the number I want to put out here. And now I'm going to go ahead and do my synthetic division. Remember, you always take the first number regardless of what it is and drop it down. And then it's a process of multiplying and adding, multiplying and adding, multiplying and adding until you eventually get a number in here. So I'm going to multiply these two numbers together to get 12. I'll put that underneath the negative 16. Then I'm going to add those two together to get negative 4. Multiply again to get negative 16. Add these two to get negative 16. Multiply to get negative 64. And then I can add these two together, and this number that's in that little rectangle is eventually going to be my remainder. And so if I add those together, it looks like I'm going to end up with negative 56. And so how I would write my answer, remember that this 3 represented x to the third. When I divided by a linear term, this is going to drop this down to 3x squared. So this represents 3x squared, and then it just drops in degree. This represents the x term. This would represent the constant, and then the number inside this little half rectangle, that is your remainder. So it's minus 56 over, remember I'm technically dividing by x minus 4, and this is how you should write your answer. I don't want to see remainder negative 56. That's not what you should be doing. Alright, there's synthetic division. Have any trouble with any of your other homework? Feel free to come in and ask for help.